All right, guys. 15.4 is going to talk about evidence of evolution. And again, this is another one of my favorite sections within this chapter. I tell you, remember FAME here: fossils, anatomical, molecular, and embryological. These all support the theory of evolution, and each on its own is just amazing with the amount of evidence that we have. I go back and forth on which one I think is the most compelling, and that just shows you that it's one that's not the overwhelming. It's just each one of these is just like a pillar to evolution, and it's just awesome within each one of these. I mean, if you're making me choose a favorite, obviously it's probably going to be fossils, but this is some of our best evidence of evolution. I would say in the like before our time. Less than 1% of species become fossilized, but what a fossil basically is remnants of a living organism. You can see here there's a specific process that a organism has to go through, so not all organisms will be fossilized. Something I do want you to know is something called the law of superposition, and this is just detailing that the life at the top is older than life at the bottom. So I shouldn't say maybe order, more complex. But life at the top is younger, essentially, so it's more recent. I don't know if I made sense there. Again, life at the top is essentially closer to our time period, but it's more complex. Life that's down or layers that are further down is older, but it's a lot more simple, if that makes any sense. So what that means is complexity of these fossils increase as you get closer to the top. We have things called transitional fossils. These are just intermediate forms of one species to another, and we see these all the time. Tiktaalik is one of them. We talk about Tiktaalik in your book, Your Inner Fish. Archaeopteryx is the transition from dinosaurs to birds. And with these transitions, we see anatomical features that are resemblant of the original species, so that transitional fossil. So you can see here, you can see the humerus is again correlated to this Tiktaalik, and you can see the ulna and radius here also correlates, and then we have like the phalanges, the digits here, and we see this in all species that evolve from Tiktaalik. Now, there is something called it's like the fallacy of the transitional fossils. But basically, each time we get a transitional fossil, that actually opens up to more transitional fossils. So there's no way to get every single transitional fossil between one species and the next. You're always going to have a transitional fossil that we don't have, just because you can see here there's now four gaps instead of there being one gap. So when somebody says there aren't enough fossils, they just haven't looked at the fossil record. Being an amateur paleontologist, there are just so many fossil records or fossils out there to complete our fossil record. You can see here, I love that this comic's pretty much saying where on this scale does it go exactly from blue to red. You can see here, you can't really point at one specific spot and say, hey, this is the transition. Um, Again, there's no missing links in biology. Anatomical evidence. This is what we see in anatomy, and again, this is another great area of evidence for evolution. You can see that all of these structures evolved from that Tiktaalik creature we just talked about. You can see how each one of them is different within different species, and they all come from this lobe-finned fish from ancient about 375 million years ago. You can see all of these primates evolved from a common ancestor that had those five fingers, and they all developed and evolved in specific ways. You can see our fingerprints are very similar to the ones of fingerprints of gorillas, meaning again, we share a common ancestor that both had those fingerprints. Analogous structures are a little bit different. We see these analogous structures kind of like a coevolution, or I'm sorry, convergent evolution, which pretty much says like certain adaptations have evolved several times, and so we know that they're a great advantageous to have. So like wings, it's a really great advantage, but each person, or I'm sorry, each species evolve wings in a different way. Like the legs are a great mode of transportation, but they're going to evolve in different ways. Like a horse leg and an insect leg are not. They're not homologous. They're analogous. The wing of a flipper and the wing of a fin, like a regular fish, are a little bit different. However, they have the same function. Same with the wings of chickens. Vestigial structures, these are just structures that are left behind, and they don't have a use in the organism that we see today. So, like snakes have a pelvic girdle. They don't have legs, but they obviously used to, and they're just remnants of these evolutionary adaptations. Whales also have that pelvic girdle because they evolved from mammals. They evolved again millions of years ago, but basically they still have that pelvic girdle that's a remnant of that transition. I think there are tons of these, and I'll talk more about them in class. But another place of evidence would be molecular, and this is again another huge area of evidence for evolution. Basically, every species is has some portion of DNA that they share with another species. Us and like chimpanzees share like 99% of our DNA, and the more related two species are, the more in common they're going to be. The less two species have in common, the less related they're going to be. And this is where we get again some of the craziest. Not say crazy, but like just really important data. You can see how much of our DNA is similar to each of these, and it shows again evolutionary relatedness of those species. Lastly, we have embryological, and this is an area that I have been learning more about myself. But basically, as the embryo develops, you're going to see the transitions of the embryological stages within your common ancestry. So again, you can't really tell the difference between all of these organisms at their embryological stage, especially early on. What happens is you have certain genes get turned on and turned off, and you develop differently as you develop in the womb. So you can see at the end, yes, you are going to have these differences, but in the beginning, they're going to look very similar. And again, that just shows evolutionary relatedness of the species together. All right, and that's where we're going to end chapter 15.